My name is Boris. I'm a developer advocate at Google, and I'm focusing on performance-heavy apps. And this presentation is I want to share with you the best practices and the mistakes I have seen while consulting partners on their Android apps. So if you have a small app, forget these slides. So let's get started. Basically, what I wanted to show, if you have a large app, the bunch of rules of the thumb that I'm working with the data-intensive Android apps. Usually the app that I'm looking at has a long launch time, janky scrolling, or even in the worst case, being unresponsive. And we are going to see a bunch of ways how can we make those things better, faster, and in the end of the day, to delight your users. Because in the end of the day, we all want to be successful. Our first friend in things that we need to fix is activity leaks. And let's see why do they happen. So activity leaks, or memory leaks in general, are extremely dangerous. Why do they happen? If we hold the reference in our code to unused activity, we hold all its layout. And layout, in turn, holds views. And that results in many, many pixels you don't want to store in your memory. Another really problematic thing is keeping static references. Don't forget, both activities and fragments, they have a life cycle. So once we have a static reference, this either activity or a fragment will not be garbage collected. And this is why static references are dangerous. They became a dangling pointers. And I have seen this code, mStatic activity equals static fragment, get activity too many times, unfortunately. And in one occasion, it took 2 weeks of my life to understand why the app was crashing in unexpected times. Really, not my favorite activity to run after those bugs. I hope not yours as well. So we start with the first easiest way to make a memory leak is by leaking listeners. Say we have the following code. Public class leak activity, extends activity, and guess what? We have some nasty manager, unfortunately it's a singleton, and we add activity to this manager by add listen this. So if you want to see more details in the blog post that I posted in Android developers, maybe 3-4 weeks ago, what happens is nasty manager holds our activity. So the activity might not be presented, but it will be in the memory. And this is really, really bad idea. And let me show you in a second how to fix it. Pretty easy. On destroy for our activity, we just unregister ourselves. Of course, we have a better discussion. Should we use singletons in the first place? Usually, we shouldn't. But sometimes it's the only solution. That's why software engineering is interesting. We have a trade-off and we have a design. So please don't forget to remove your listeners. In order for us deeper to understand why these problems happen, you need to remember the structure. What does it mean to be an inner class? So for instance, in this lovely drawing, you see the handler, which we will look shortly, which is an inner non-static class to the in-scoping class, which is activity. As we are going to see shortly, as long as handler alive, the bounding activity is alive. If you don't believe me, try to read JVM spec. This is funny. And this is another memory leak to represent the example from the previous slide. We have activity, public class, main activity, extends activity, and inside we have a handler. excellent way to reproduce, to communicate things. Handler, asynchronous communication, thread safe, all good things. However, and I believe this code looks legit for you, what happens if you have the following code? Handler post delayed next hour. Oops. What does it mean? It means as long as the handler has a message, it's alive. And if a handler alive, it's a closing activity alive, even though we might not need it, but we pay for the memory. This is what we call in software engineering a memory leak. Okay, let's see how we fix it. I have a confession to make. The fix is a little bit tricky. Okay, but let's see how to fix it. We really recommend using weak reference. What's a weak reference? If you look at the Java language spec, I don't remember which page, I believe around page 300. Yeah, sometimes I used to impress my employers by stating pages from the spec. It helps. This is a good tip, but I prefer not to put it in slides. Weak reference, if it's the only reference to underlying object, the garbage collector will clean it. That's it. Truly simple. How does it work here? Pretty easy. We declare a handler with a weak reference. So if the handler is alive and we don't need the activity, and the weak reference that the handler holds is the only reference, tick, the activity is cleaned. I admit this fix is a little bit tricky. But again, this is something you and me, as an Android developers, we need to understand it. This is the system, this is the ecosystem that we are living in. And this is to recap, for the ones who definitely lost me in the last slide. This is the inner class, like a handler. Inner non-static class can't live in isolation from the scoping class, which is activity. So please, when you come back to your code, please take a look on all your inner classes and make sure that you don't have a memory leaks there. You and your users will thank you later. On general, please prefer static to non-static inner classes. Basically, the difference is non-static inner class is not bounded to enclosing class, such as activity. And please know that both classes, handler and activity, have a different lifetime. And this is one of the reasons for the most annoying bugs that I have been seeing. As I already told, most of the time what I'm doing is, first of all, making you guys successful on Android, but I'm working with companies trying to sort out their problems. And many of them come to me with memory leaks. This is why they're the first one in our bucket of things that we need to improve. So, what can you do about activity leaks? Please remove away static references. Consider using event bus to decouple listeners from senders. Please unregister your listeners. And in general, please prefer static inner classes to non-static ones. What you can do more? Please do code reviews. Based on my personal experience, the code reviews are so far the most effective way to find memory leaks. Each app is different. The apps are big. The logic is complicated. And as an added bonus, when you do code reviews, and if you do them well, you understand your application structure, which is really important. Consider, of course, using tools such as MAT, Eclipse Analyzer, Leak Canary. And another thing that really helped me well is printing logs on callbacks. So I see that on create of activity was called, however, on stop or on destroy wasn't called. This, I know that I might have a problem. Any more questions about memory leaks or activity leaks? All right, let's move on to our second group of friends, scrolling. Who likes fast scrolling? Only 2? 3? Okay. My scrolling will be fast, your will be slow, I'm better. The secret for effective scrolling is as follows. Use UI thread only for UI. If you do it, you solve 99% of your problems. And let's see how. Don't do the following on UI thread. Never load images, never do networking calls, don't pass JSONs, and don't do database accesses. There are means to do them. Some of them even fast. And we in the coming slides are going to see how. I definitely recommend for images, networking, JSON, using libraries. There are a lot of community solutions, and some of the best presenters are even here in this Droidcon conference. And for database access, consider using loaders, who actually do batch updates to databases, and to make you focus on what's important in your app. And let's see how and why. So as for image libraries, the following provide usually the required functionality. It's based on our experience working with leading companies. There are excellent libraries such as Glide, Picasso, Fresco. Just know that they have all a different design trade-off, especially around large images count. For instance, if I remember correctly, following the excellent talks about Fresco, Fresco uses native memory and HMEM. Glide has a big byte array spool to speed up images. Memory. Yes, we managed to convince ourselves that the bitmaps are tricky, basically because of large size and fragmented heap. That made my life not an easy one when I was responsible for an app with a lot of images on the pre-4 devices. Also, memory management is tricky. Some of the stuff it's better to put in file, and some of the stuff it's better to keep in memory. Please note, we have the following class LRU cache, which is part of the support library, in case that you need a good and efficient cache implementation. Networking. First, the problem with the Java networking, which made its way into Android, is, again, the APIs are tricky. And if you don't know or know, many Java Net API calls are blocking. This is another excellent reason. Please don't do networking on the UI thread. Please know that stream calls are blocking. And to make things even more interesting, equals of the URL class result in DNS call. This is time that you are paying. Again, don't do networking on UI thread. Use libraries or any other threading solution that fits your problem. Basically, the hard part about the networking is doing async HTTP. Please know that if I remember correctly from Android 4.4, OKHTTP is the part of Android sources. However, if you feel that you need the latest version of OKHTTP with some stuff that hasn't made its way into the official Android, consider bundling your own. There is another parallel library which is made by Google, Volley. There is an excellent library made by Square. I think it was also presented yesterday, Retrofit, to abstract your REST calls. All the solutions you have to make your app network-friendly, successful. Large JSONs. Yes, this is another component of things you shouldn't do on UI thread. Because parsing of large JSONs has a performance effect, especially if a class, or converted to a class with a lot of getters and setters. So what we have found so far is if you have a small JSON, the JSON, also made by Google, gave the best results. However, if you have a large JSON, then question? Yes, please. First, thank you. This is an excellent question. I'm always asked about it. I would say JSONs are also different beasts and creatures, so it depends. However, I would consider a rule of thumb, I don't know, maybe less than 500K could be small. Anything larger could be considered as large. And also, don't forget, this is a moving target on strong devices such as Nexus 6, etc. The large, something that we consider as large is small, but if your app has to support previous devices, then definitely you should take it with a grain of salt. But again, thanks for the questions. Right on time. Each time I present it, I get it. Excellent. That means that I'm doing something right. So for large JSONs, I would say the best to use or the fastest to use are JSON and Instagram JSON parser. So they did a really interesting work of generating the stream parser code let's say during the development time, and then you have to add the generated classes back into your project. But what I have been talking to companies, IG JSON parser delivered them the best results so far. This you should know by heart. These are the tests you are going to do to make sure you are not on the UI thread. Thank you. Let's move on. So, what can we do to speed up our scrolling? Because as we agreed, we love fast scrolling. Please keep UI thread only for UI. We are going to talk in the next bullet about concurrency APIs. So hold your appetite. Please use libraries. As with for stuff around the JSON, caching, memories. The reason to use libraries, because the code is tricky. That doesn't mean you can't write a good library by yourself. However, if I were to choose, should I focus on something which exists versus providing more value to my business, I would definitely go for providing more value to the business. And again, don't forget, developing a library is something which is expensive. And if you have libraries right off the shelf, consider using them. You know, they are supported, they are maintained, there is a community knowledge, whatnot. And we are to our next bunch of friends, which are around concurrency APIs, which I find them really important to understand in order to make your app fast and responsive. Please remember, and unfortunately people forget it, service methods run on the UI thread. Myself included, made this mistake more than once. I thought, okay, I'm shifting stuff to service, maybe it will behave better. And then I was disappointed, each time. Please consider using intent service, async task, executors, handlers and loopers. Basically, I'm afraid I will not have enough time to talk about handler threads, handlers and loopers, but there are the slides, which basically the material is in the appendix in the end of this presentation, which I put. So let's focus on the trade-offs of the first three friends. Intent service. In my previous company, I used the intent service to perform uploading to the server. Basically, what is intent service? This is single-threaded, simple, one job at a time. We don't have any job system, meaning we can't keep track for jobs. And we have essentially no normal way to stop it. So if you have some large operation that doesn't touch UI, consider using it. What I did in my previous company was doing uploads via intent service and showing a notification icon once I'm done. Async task. This was my good friend, because it's tricky. Essentially, the async task is the solution if you have a thing that you need, or basically something that you don't care about result outside of UI. However, please note, even though that async task is relatively easy, it has some dark corners. Activity lifecycle, especially during rotation, please make sure that you close and dismiss it. Otherwise, it could cause memory leak. And as we have seen on our first bullet, memory leaks are not fun, especially around activities. Another thing that I had problems with async task is it was changed rapidly around honeycomb and gingerbread. So what I did, I forked the async task sources from the Android source tree, bundle it to my APK, and that's it. Sometimes this could be a solution. And of course, we have a slide to talk about it. Executor framework. This is another friend in the concurrency APIs that we got from Java 6 and on. This is essentially a thread pool managed by the system, which has a callbacks, futures, and mostly I use it for MapReduce tasks. Meaning, if you have a big job and you want to break it into small pieces and give each piece a thread, the executor framework could be your best solution. For instance, I used it when I wrote my open source GitHub project, MapReduce on Android, I think 3 or 4 years ago. Even though it was running on Nexus S, you know, Android, the dark ages, Nexus 6, once we used this device, horses, carriages, it performed extremely well. And I think I wrote the first MapReduce on Earth. So, what you can do about concurrency APIs? Please learn and understand the APIs and trade-offs. Please make sure that you map the correct solution to the right problem. Understand what are your problems and see which of the API that I presented before can fit the best. There is no perfect solution, you know. In the room full of software engineers, if any two agree, this is a majority. Please refactor. This always helps. And with that in mind, we are going to our next friend, deprecation. Who you know what is deprecation and why we should avoid it? Good. More hands? Want to tell us? Answer from the audience. Why deprecation is bad? Exactly, thanks. So let's see why. And also, not only deprecation is bad, system abuse is bad. And this is going to be a classic example. Please don't call private APIs by reflection. Please don't call private native methods from the NDK and C level. Please don't use runtime exec to communicate with processes. And ADB shell AM to communicate with other process is not something we want to support. I have seen zillions of bugs, especially when we introduced Android L, when we blocked this feature. Companies were calling me and saying, my app doesn't work. And unfortunately, my answer to that was, guys, please don't abuse things, especially private APIs. Private APIs are meant to be private. That's why we can change them. This is what is the notion of API, public versus private, as we call in our courses in software engineering, encapsulation. And let's get back to the deprecation. So basically, what does it mean? It means that some API will be removed. Then in one shiny day, usually 1 or 2 days before the major release, your app will not work. And to make things even worse, sometimes if you are dependent on the old version of a library, there is no way to update both APIs and tools. Unfortunately, I have seen a company whose whole application was dependent on library who could only be built with Android version 3. Android version 3 was long time ago. This is a bad thing. Please don't do it. And basically, if you ask, why do we deprecate APIs? And most of the time, there is a compelling reason to do so, especially around security, stuff that we fix, correctness, and of course, performance. So what can you do to avoid deprecation problems? Please know and use APIs, and from time to time, and better more than less, please refactor your dependencies. I know, this is a development task, but sometimes it's the best way to sort it out. And of course, newer is better. Please prefer toolbar to action bar. Please prefer recycle view, especially for animations, because it's optimized for that. And as a latest and greatest example, if you guys don't know, but we removed the Apache HTTP connection NM. By the way, it's still available as a Gradle dependency. Please use HTTP URL connection. It has a simpler API, smaller size, transparent compression, better response caching, and other cool things. So, to sum up deprecation, please don't abuse the system. It will backfire you. And please update your dependencies and tools. And we are to our next friend, architecture. And let me give you a small spoiler. From what I have heard from the companies I'm working with, bugs around the lifecycle and architecture are the most prominent and the most annoying bugs. And let's make sure that you have less bugs of this type. So, please understand app components lifecycle. You need to understand very well what is activity, what are the flags around activities, what are fragments, what are stated fragments, what is task, and what are flags. Either read documentation, but what helped me most to understand this stuff is adding logs on callbacks. Just add a simple callback line, and then you can play around and see what if you change this flag to that flag and how does it change. Please work with framework and not against framework, because as you know, framework components have a purpose, which are specific semantics, and use when these semantics are desired. Don't you, there's a reason we have a broadcast receivers. There is a reason service is different from activity. On general, please don't over-engineer. Unfortunately, I also have seen too many cases when I talk to companies about their architecture, and they just create unnecessary layers of mud above the framework components. Don't do it. Keep it simple. Then, you know, you have a less price to pay. Your app performs better, and other good things. And also, I'm asked one of the most also prominent questions that I have been hearing from companies is, what's better? Should I pick Picasso or Glide? Should I pick Volley or OK HTTP? And usually there is no, let's say, right answer or 100% correct answer. However, the following checklist is something that I'm using when I'm discussing with the companies what they should do in terms of architecture. I would say when you consider a third library, make sure it solves your problem. Make sure it plays nicely with your current dependencies. I have seen a partner who uses Dagger, but unfortunately he couldn't pick another library because it doesn't have Dagger bindings. Please know DEX method count. Nowadays it's less of a problem since we introduced the multi-DEX flag. However, it's always good to know and always a good idea to be aware what's going on. please check the dependencies, because last thing that you want is a dependency clash. You have a version Z of some library, but the third-party library requires a different version. This is what is called, at least in Windows world, the DLL hell. I guess in Java world it's more of the jar hell. Try to avoid it. And also know the maintenance. And something that we introduced in M, and if you have any question, I also shall be more than happy to answer, is the runtime permission that the library requires, which is also a consideration, especially after M. All in all, speaking of architecture and design, the best idea is to design your app sleeping most of the time and to be extremely responsive when it's awakened. For me, the best app is the app that gets out of my way in less than 10 seconds. So all in all, what I can definitely recommend you to do about the architecture is do it consistent, which is a cornerstone of every architecture. Make sure you can get people on board quickly. Always have helps to have somebody or someone who is experienced in that architecture before. And in general, please pick your dependencies wisely. Let me thank you. We still have, I think, 7 minutes before the lunch break. I'm sure I'll be more than happy to answer here any question that you might have. This is my site where I put all the updated slides from time to time. You're welcome to look at me, to follow me on Twitter, G+. I'm here. And thank you very much, and good luck in your Android adventures, whenever Android will take you. Thank you.